All right, so today we're doing Java 4 lesson 7, and today we're doing an interesting and pretty important topic, recursion and searching methods. So it's a bit of a long one, but hopefully we'll get through it. Right, so starting off with recursion. A recursive method is a method that calls itself repeatedly without the user having to type the call method many times over. So you can kind of think of it like recursion. That's kind of already saying that something's going over and over, and that's a way to remember it. So we're starting off with some examples like I usually do with these slides. So first you can see like part of it, like the code continues on the next page, but this is part of it. And you can see that we're already calling a method with a number in it as a parameter. So this is the rest of the code. And so it's a method named print, and you're taking in an integer parameter. So if we're first line says if n is equal to 0, then it returns. So I guess one thing I didn't mention before was that you can do return even if it's void. It's just that you can't return an actual value. So you couldn't say return n, that wouldn't work. But you can use return to signify that end the method right here. But like for void specifically, you wouldn't return anything specific. You just write return and then semicolon. Otherwise, you'd have to write a value, but otherwise it's fine. So this is what we call a base case, and base cases are what we use to as like a stopping point, because you can see here that we have a print n-1. So this is a method call like you probably know. But if you notice that if we didn't have this base case here where we were saying if n equals 0, then return the method and stop executing the method, then it just go on forever and ever. It just go n-1, n-1, like continues to go on for like the rest of the code, which is not good because that ends up becoming an infinite loop. So we always need to have the base case here in order to prevent it from becoming an infinite loop. So we have the method call here, and generally you want to have a condition, like you want to do something with whatever the parameter is, like here, to make it so that it becomes this base case, or else like you're defeating the purpose of a base case then. So in this case, we're saying that n-1, assuming that n is greater than 0, or equal to 0, that is. Just notice that if it was equal to 0, it automatically turned. But yeah, so we're calling it over and over again, and we're printing out n after that. So the output of this, if we're looking back here and we're entering 5 in, then it'd be 1, 2, 3, 4, 5. So you probably are a bit confused about that because we're entering 5 and then we're entering 4 and then 3 and then 2 and then 1. Supposedly, if we're looking at this regularly, you would assume the output to be 5, 4, 3, 2, 1 instead of 1, 2, 3, 4, 5. But I'm going to explain it in a second, so we'll see why. So a drawing, but made by me, kind of bad, but we'll deal with it. So this is the drawing that details for this specific code above. So it's kind of messy, and I'm sorry again, but follow along with me and then you'll probably see. So we're starting with n equals 5 because that's what it is originally. So if we're looking at the last 2 bits of code, so this line right here, the method call and printing. So we're first printing, like doing the recursive call, and then we're printing. So how it works generally is that the printing call goes first. So that's why we do this part first. And essentially it's like creating a bunch of layers, but you're executing each one. So originally, if you only look at the n equals 5 part, only this was there. But then because this method call goes first, it has to execute it. So it then calls print 4 because 5 minus 1 is 4. So, and then n equals 4 in this case. But notice that this case, you're not ending it yet because you haven't gone back to this to print out n yet. So this is still open. It's just waiting for the method to go back there. So if you go along, go do n equals 4 now. And again, because the method calls first, then you have to execute the method call first. So then it calls print 3 because 4 minus 1 is 3. And then you can see the arrows. It goes up to here, n equals 3. Again, this thing is still open, and you can kind of tell like where this is going. So continues to call a method call, goes to n equals 2, and this is method call again. So it goes to n equals 1. And then again, method call goes first. So you would then execute n equals 0. But notice here again that we have a base case that says if n equals 0, then it returns. So that's what you see like right here. And by returning, you're basically saying stop the method, stop creating any more of those layers, and you're going to essentially return. Like you can kind of think of it like that way. So when it says return, you're basically returning to all the other layers. So n equals 1, n equals 2. You're returning to all of the other ones to finish executing, and then that would be the end. So that's why when we're returning, you can see that I have arrows going back. And just notice how, like, when it returns, it always goes back the way it came. So it doesn't go from the beginning, like from n equals 5 and then down. It always goes from wherever it is back through the way it came. So in that case, you could probably see why it's 1, 2, 3, 4, 5 for this one. So when it returns, you can see arrows going back. This one prints 1 because in this specific case, n is equal to 1. So that's also another thing to take in, is that it always prints out whatever the value is for this specific case. Of course, like you're probably going to implement other stuff rather than something simple like this, but it's generally important to remember. So because you're printing out n here and n is equal to 1, it prints out 1. Same thing, because n is equal to 2, it prints out 2, goes backwards, prints out 3, prints out 4, prints out 5. And again, when it comes to here, it seems that there's nowhere else to go because we didn't get beyond n equals 5. So then the method ends there, and that would be the output. So that's why the output is 1, 2, 3, 4, 5. Hopefully I explained that correctly or detailed, but you can always look at this drawing later, even though it's like kind of bad, but I think it explains basically what it is, as long as you kind of know what I was talking about. All right, another example. So there's 2 examples mainly of this that I had to show. So you can see that we're using the same method. I just changed up a bit. So we're calling print 5 again, and you can see that the base case is the same, the parameter is the same, the return method, like the return type is the same. The only difference this time is that we swapped these 2 essentially. So the print statement is in front of the call this time. So this time the output would be 5, 4, 3, 2, 1. So I don't know if you guys could, like looking at the last one, if you guys understood that one, you guys could probably figure out this one. But we're gonna go to another drawing of mine that is also kind of bad, but we're gonna go with it. So again, we're starting at n equals 5. But this one you can see that I wrote the print statement first and then the recursive call next. So that's the thing. So this time, because we're not doing the recursive call yet, which means that we're not doing another layer yet, that's because that makes it so that you're printing it first and then you're calling the next ones. So yeah, so basically we never have to, how to explain this? Sorry. It's basically so that like when you return at the end of it, it's not going back through it since it already returned. Sorry, it already printed out. So it doesn't have to go back and print because, yeah, you'll see in a second. I'll like go over it more detailed and you'll probably see. Okay, so again, because it prints first, it prints out 5 here. And then you get to here when you're calling it. So, and then it becomes n equals 4. And similar to the other ones, you can probably see this prints out 4. And then n minus 1 goes to here, n equals 3. Prints out 3, n minus 1, n equals 2. Prints out 2, calls it again, n equals 1. Prints out 1, prints n minus 1. And then again, like with the n equals 0, because it's 0, then we're saying return. And similar to the last one, even though there's nothing else to execute, the method still goes back through everything. So that's why you can see arrows going back. So it goes back, but since there's nothing after it, and you can see back in the code here, there's nothing after it. So there's nothing to execute, which means it doesn't print out anything. It doesn't return anything. It doesn't do anything like that. So that's why you don't see any output indicating that. It's just going backwards through it. So it's more of like a conceptual thing rather than something that actually depends. Sorry, I'm not explaining this correctly, but the point is that there's nothing after it, so there's nothing to execute. But it still goes back regardless. So goes back, goes back, goes back, goes back, goes back. And then again, because there's no layers after it, then the method ends. So that's why it'd be 5, 4, 3, 1 this time. And again, that's because, again, you're printing it first rather than waiting until later to print it out. But that's the complexity of a recursion statement, recursive method, really. But hopefully you guys understood this. Explanation and notes. So this basically goes over most of what I talked about. So again, I think you can see now, but the difference between outputs is because of the different placing of the recursion statement. So with each time that the method calls itself, it creates another call of the method. So like I said, kind of like layers. So it doesn't get to the print statement, and instead it keeps calling until n is 0. When it returns, then the program starts working backwards, going to every single call of the method and running it to completion before ending the code, which is why the numbers come out backwards. So again, that's basically what I mentioned for the first example. But yeah, this is here when you're going over it and you need it. So this is explanation of the second example. So in the second example, it already prints the numbers out on its way down to 0. This also means that when the method call returns, every layer would already have been executed, so nothing else would execute then. If you have recursion as return, then you won't continue on to any statements after it when you go back to it. So I think I have an example of that when later, but yeah, so basically, if you're returning something like, so not like here where it's like just regular n minus 1. If it's saying that we're actually returning a value where it's like int or something similar to that, then because you're returning it and that's signifying the end, it's saying that after you execute all of the method calls inside of that, then when it comes back to it, it's automatically returning. So it automatically doesn't go to anything after it. That means that if you had anything after it, it's never going to be executed, like ever. All right. Yeah, but that's, I think I have an example a little bit later, but if not, you could probably figure it out. I mean, like, I think as long as you got the recursion part of it and how like different outputs affect it, then I don't think you're gonna have like a major problem with it. And like expecting that like my explanation was good enough, that is. But anyways, moving on to the next slide. Okay, notes. So in recursion, it is required that you have a base case, or else you might end up with an infinite recursion method, like I mentioned. So usually it would be an if statement with a condition, then the return statement. I think you should almost always do that, unless there was something else, but generally do that. Since like the return statement basically operates the same way as a break statement in a loop. So if you don't do a return statement, then you're kind of gonna get constantly going. Since you could probably tell that like something like break wouldn't do anything in a method unless you're breaking out of the loop. But yeah, otherwise always do like an if statement with a condition, then the return statement to make it stop. And also just make sure that the recursive rule that you set up will end up at the base case, or else it defeats the purpose of the base case, like I mentioned. So what it means by recursive rule is just like the n-1 thing for the examples that we had. So that's the recursive rule. So it's basically just saying that make sure that ends up at the base case. These are also like stuff that I'm gonna ask that is required. So try to remember this part. Anyways, moving on. Sequential searching. So we're going over two searching types. We're going over sequential searching and binary searching. So this one's the first one and probably the easier one to understand. So sequential searching is a form of searching through an array or collection one by one until you find the value you're looking for. So this is just a typical looking through and like the looping through and looking at values. This one, even without the example, I'm pretty sure you could probably like code it yourself since it doesn't require any fancy stuff that we already learned. It only requires an array list or an array and then loop. So yeah, example on the next page. So going to that. So we have an array here. And then you can see that we're just using an enhanced for loop in this case. So int I for array. And you can see if we're saying if I is equal to 5, then we're saying system.print. I can't speak today. Okay, sorry. System.print found and then break. So of course, since there's a 5 here, then it outputs found and then it breaks out of loop. So we're kind of saving some computational time there by breaking out of it. Yeah. Again, like you could probably code this yourself without ever looking at the example. So I don't think you guys are gonna have a major problem with this since you guys done like much harder stuff than that. But yeah, this is a typical example. Of course, you're probably gonna do some more like complex stuff with this rather than just searching for one value. But this is like the basic one. Binary searching. So this one's the slightly harder version, depending on how you look at it. So binary searching is a form of searching through a sorted array or collection. So how we get the sorted array or collection is something discussed later, specifically next lesson. But sorted array just means that it's going in like the regular order or in some other order. And like you can like make it sorted without ever touching without ever manually sorting through it. So that will be discussed later. But right now, just make sure that all of your arrays when you're testing is sorted. Otherwise, you're not going to get a correct answer. So it's where you first locate the middle of a collection, then compare the value with what you want to find. So compare the middle of it, then compare it to the value. So if it's equal to the value, then the search is done. If it's greater than the middle, if the value is greater than the middle, then the search blocks at the values lower than the middle for consideration and searches only the upper half then of the collection. So it's a lot more efficient than sequential searching since as you can imagine, sequential searching, if you had like an 1,000 item array and then you have to search every one of them, that's going to take a long time. But if you think about binary searching then and searching, then that becomes a lot easier and makes it a lot easier. Okay, yeah. So this one's the slightly more complex one to code, but it's also the one that's more efficient. So it'd be really a good idea to know this. But also, if you think about it, it's similar to like that game that a lot of people play where it's like, guess a number from 1 through 100. And this is similar to it, where it's like, you kind of rule out different possibilities. So usually you'd first guess 50, and then it'd say, oh, it's greater than 50. So then you only guess 50 to 100, right? So that's similar to what we're doing now. And that's probably going to be a problem later on. So, right. Sorry, I got sidetracked there. So we're saying that if it's greater than the middle, then search blocks out the values lower than the middle for consideration and searches only the upper half of the collection. And there it finds the middle of that specific part again. So the middle of the upper half of the array and compares it to value again. And next slide. And so on. So compare it to the middle and the value. And then if it's greater than, blocks out the lower half. If it's less than, blocks out the upper half. And then so on until it finds the value it's looking for. So again, like same thing if it was lesser for the middle. So if the value was lesser than the middle, then it'd block out the upper half and then only search the lower half. So you could probably see how this is more efficient than sequential searching. So there's two ways the search can be programmed. So usually it's either programmed through recursion, so the thing we just went through, or regular while loops. So I have implementations and code for both of them, so you'll see them in a second. The data collection can also have multiple values, duplicate values, if you wanted to. That would also work. But anyways, implementation. So this is like a worded version of how to implement it. It's not the actual code, of course, but it's like step by step how you get there. So for implementation, you first have to set a window where the binary search will occur, which will narrow down as you progress through the search. These will usually be variables that contain indices. So one should be 0 and one should be array.length -1 in the beginning. So you'll see more what I mean by that in a second when we look at the code, but yeah, generally you can't just have a while loop and nothing else. You have to set boundaries. And usually that's with the variables that like hold the windows where you're searching through. So we're talking about like, how to implement it while loop version, but remember that you can implement it through recursion as well, and you'll see that in a second. But we're talking about while loop right now. So with a while loop, you do the condition low is less than or equal to high. Then you create the middle values index. So again, you'll see that in a second. First, you compare it with the value, then you compare it to see if it's greater or less than the value. In this case, you'd probably use number comparison symbols. You adjust accordingly by adjusting the window to whatever it ends up being. After the loop, you have if statements testing whether the index you got low, which is one of the variables that you would use, is equal to the value you're searching for. So this would be the general binary search, though there would be slight modifications if you were deciding to move this search to another type of data structure, such as the method. So in that case, recursion. Just note that you could just put this in a method and it still work. Like if you just did a while loop and then pasted it all into a method, that would still work, but it's not recursion. So remember, recursion specifically when you have a base case and you have recursive call, and that's what counts as a recursion method. But if you just plop this while loop inside a method, then that's not a recursive loop. Right, the drawing. Just to illustrate more, like how binary search works. So let's just say we had an array equals this, and then the value we're searching for is 2. So again, notice that like the array is sorted, so 1, 3, 5, 7, 9 in that order. So what, like again, like first we have to set a window, and in this case we're using array indices so that it's easy to set with integers. So first we do a low equals 0, and you could probably see that in the implementation. I mentioned those variables. So low is always in the beginning 0 because that's the lowest variable, like lowest indice. High is always array.length -1. So in this case, it's 5, and then -1 is 4. Mid, how we calculate the middle value, you could probably tell in a way, is you add low plus high, so 4, and then divide by 2. So the mean of those two. And it'd be mid equals 2 for this case. So then we're saying if array.mid, array.mid is equal to 5. Yeah, and you can see 0, 1, 2, this is equal to 5. Right now it's 5, and if we compare it with the value, which is 2, 5 is greater than 2. So that means that we have to X out all of the upper values. So in this case, we include 5 because we already know that 5 is not equal to the value. So that's why we cross out 5 as well. And so you can see we cross out like everything in the upper half. So in the case where only end up with 1 and 3. And then we have to reset those values. So in this case, mid was originally 2. And we already X out 2 index. So we have to move high, the new high, to 1 because you can't have a 2 index right here if it's not there. So yeah, high is equal to 1, low is the same. Mid, we have to reset it again. And you can see that 1 plus 0 is 1 divided by 2. But in this case, remember again that we're doing integer division right now. So it's not going to come out with a decimal number. It's going to come out with whatever the answer would be, but like cutting off the decimal part. So in this case, it'd be like 0.5 in reality, but since we're cutting off the decimal part, it'd only be 0. So if we're doing AR mid, so AR is 0 basically. If we're looking at this array, then it's 1. And 1 is less than 2. So then we cut out the 1 part. So we only have a 3. And in this case, low is equal to 1, high is equal to 1, mid is equal to 1. So in this case, there's no 1 index, and it's automatically just going to test whether 3 is equal to value, which is not, so it ends up being not found. Right, the code. So this is the while loop version. So sorry, my voice is a little bit crackly today, but you can see that we're setting a value here. So basically the value we're trying to find. And then we're doing int low. Oh, I need to write this. Okay, like disregard the commenting. It was just when I was trying to decode stuff, it happened to be there. But ignore those. Those are not important. So sorry. Okay, so we're setting an int low again, and then that's always 0. Int high, AR.length -1. So if you're looking at the commenting, it's 4. And then we also set a Boolean found equals false. So that's just basically so that when we do find it, we can set it to true, and that makes it easier when we're okay. The thing's blocking it, but that makes it easier when at the end we're trying to find whether or not we found it or not. And you can see like the system.println found part. So you can see the while loop part, while low is less than or equal to high. we're setting it into mid here, and low plus high divided by 2. And then you can see it's kind of similar to what we had before. If array mid is equal to value, then we're setting found to true because we found the value, and then we break. Also, if AR mid is greater than the value, then we're doing high equals mid minus 1. Since, again, remember, since so because that means that it's greater than, then we have to move the high down to where mid was, but like minus 1, because that means that mid didn't work and we're cutting out the rest of the values. So that's essentially just crossing out the other values. And then you can see that else we do low is equal to mid plus 1, because if it's not equal to, if it's not greater than, then it's less than. So that's why we automatically put an else here. So you can see how like it goes over and over again until it ends up at a value that doesn't work. And then we print out found, which would signify whether or not it was found. And that's how you do it for while loops, at least. All right. But yeah, like ignore the weird spacing as well. Since I copied and pasted from the code, from coding it, so it was a little bit weird off of that. But anyways, binary search the code recursion. So if we did the same array from before, and then we just did binary search here, AR, we're trying to find 16. The low is 0 and AR.length minus 1. So there's a reason why we can't just automatically put it inside the method. You'll probably see later. All right, so in this case, we're returning a Boolean. So first, again, we're setting the mid, low plus high divided by 2. And then we're doing if AR mid equals value, then we turn true, and that would automatically cut off the method. That was the case. You can see again, if low is greater than high, return false. So that's basically saying, you can see like in the while loop part, we're saying if low is less than or equal to high, then we continue running. But in this case, we're saying that if low is greater than high, then that's automatically false. And the reason why we're putting that is because if this goes first, if this doesn't return true at all during the recursion parts, then you can automatically tell it's false. So here we're saying that if AR mid is greater than value, and you can see like this is where we put the recursion call at the return statement. So this returns whenever it's done executing. So yeah, so it continues going here. Return binary search, AR value low, and this is where we have to put these variables in the parameters, since this is where we're adjusting the windows. So mid minus 1. Here again, you can see that it's mid plus 1. So continue running until it returns true or false, or it's done executing. So yeah, that's how recursion one works. And I believe that is it for the lesson. Long lesson again, important one, and also potentially confusing, but it's an important lesson nonetheless. And we're going to do class problems in a second. All right, so these are the class problems. We're kind of short on time, so we're going to get to all of them, but it's still really important nonetheless. Again, that you know how to do this, since it could be very confusing, especially at the beginning, and it's always good to know how to do these. So make sure you do them and you understand them. These are the problems specifically that we're working on, but these are the full problems. So try to do these though specifically, and then just to test whether you know or not. But otherwise, that'd be it for this lesson.